Sir, if you permit, we can start, sir.
जी 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 जी.
Thank you. Good evening and namaskar to all of you. Respected Honorable Professor Nageshwar Rao sir, Vice Chancellor IGNOU, Pro Vice Chancellors of IGNOU, Professor Satyakam sir, Professor Uma Kanjilal ma'am, Professor Sumitra Kukreti ma'am, Dr. Srikant Mahapatra sir, Professor Manroop Meena Singh sir, and Professor Kiran Hazarika sir, our distinguished speaker of the today, sir, Professor Anil Kumar Grover ji, former Vice Chancellor, Punjab University, Chandigarh, and all the directors of the schools, heads of the division, regional directors, and staff present at the regional centers, registrars of the university, heads of divisions, faculty members, IGNOU fraternity, my colleagues, and dear students. I extend a hearty welcome to all of you. Indeed, it's really a privilege for me to welcome you all on the webinar on National Science Day celebrations today. As on this day, Raman effect was discovered by Indian physicist Sir C.V. Raman on 28 February in 1928. And for his this discovery, he was awarded the Nobel Prize in Physics in 1930. At the outset, sir, I express my deep sense of gratitude to our Honorable Vice Chancellor, Sir Professor Nageshwar Ravji, for kindly agreeing to grace this webinar. In spite of his extremely busy schedule today, VC sir has always been a guiding spirit and always motivating, supporting, and encouraging us in the events and other functioning of the school. And under his able guidance, the university has received the highest NAC accreditation, that is A plus plus. On behalf of the school, sir, I warmly welcome you again. We are also delighted and overwhelmed to warmly welcome Professor Arun Kumar Groverji, who is our speaker of the day, former Vice Chancellor from Punjab University. Thank you very, very much, sir, for sparing your valuable time besides your busy schedule, as we have just heard from you about you were busy in some convocation function few minutes back. And we are very delighted that you will be sharing your experiences and knowledge to us today on a very interesting topic, that is a discovery of a new effect and the award of 1930 Nobel Prize in Physics to C.V. Raman, a comprehension. That will be the title. I extend hearty welcome to all guests who have joined us today. This webinar is being streamed live on Facebook and YouTube also. About the school, sir, just a few lines if you permit. The School of Sciences had 8 disciplines, and we are running programs right from awareness to certificate to UG, PG, and research level in these disciplines. And very recently, this year onwards, January 24, we have launched 8 MSc programs, and 4 years program UG is also an offer in a multidisciplinary mode, and we are also offering courses to Agniveer scheme as well. And school is having good component of research, like 116 research papers were published by the faculty, out of which 93 were there in the peer reviewed UGC journals. So with this brief introduction, sir, I would now welcome Professor Vice Chancellor Professor Nageshwar Rao sir to bless us with the kind words and inaugurate and open this discussion for the today's lecture, sir. Thank you, sir.
Good afternoon to all of you. First of all, I congratulate and compliment the School of Sciences for organizing this webinar on National Science Day celebrations, especially inviting a distinguished scholar, Professor Arun Kumar Grover, former Vice Chancellor, Punjab University, Chandigarh, to enlighten us on the eve of this uh, Raman effect, for which he got the C.V. Raman has got the Nobel Prize way back in 1930. Uh, I do have an informal interaction with Professor Arun Grover way back when he was the Vice Chancellor of Punjab University. Maybe he may not remember that.
I do remember.
Maybe you may not remember, but now you're
I
saying
remember.
I remember. So, and I think we were in coffee house there in Punjab University, and there we met and interacted. And you are so simple and down to earth person there, and all the people, they were appreciating about your role, the contribution, the vision of on reshaping the Punjab University. And a great scientist. That is what the School of Social Science, School of Sciences, it has taken the initiative to invite you and seek your valuable guidance and inputs to strengthen the research base as well as the academic inputs, which are required for our students also. I must also compliment the School of Sciences, which is contributing significantly in the university, as was rightly said by the director, School of Sciences, that they're having the PG programs, they're having the UG programs, they're also having the 4-year undergraduate programs. Especially in science, it is very difficult to have those programs and conduct the practicals at all India level. But this big task, it has been carried on by the distinguished faculty members, and they work like a team. And the result is that they are almost the first university at the global level, which can say that they all are having the 4-year undergraduate program for each discipline, and also 4-year undergraduate program, postgraduate program. Sorry, it is the 2 years right now, 2 years PG program for all the important disciplines in the School of Sciences. Publications, yes, I do agree that they have got a lot of publications, and the publications, they are being made in the national journals, international journals, and some of the faculty members, they are known nationally as well as internationally also. It is very difficult to spare time for our faculty to see the researches also, but still they all are contributing, and that is why they all needs to be complemented. Here, whatsoever they write, that is being read by learners all over the globe, whosoever is our student. So, and this material is to be written in the SLM form, self-instructional material, SIM, and self-learning material. So it's very difficult to write those things, and that is why that distinction which these people they got, that is helping a lot of the underprivileged students, and also who are in the rural areas where they are not in a position to get the science education. That science discipline is not being provided to those learners. For them, this particular facility is available. Basically, this particular discipline, it has got a lot of praise. When I was also young, and I wanted to become a science student, and of course my parents, they also wanted me that you must go for science. And there was one government which says that
Mr. Gajraj Singh, mute yourself.
there was a government school where it is being said that the merit which they are having, that I could not get that. Of course, I was a first class student. So that was the cause, and subsequently, the things they moved to me to a different direction, and thereby I am now before all of you, and still I am learning how to use this basics of science, cause and effect relationship, and how to go for a reasonable decision making process. all those things, they come when we have this cause and effect relationship of any issue, and then we reach to a meaningful inference. Lots of experimentations that is going on in the field of science, and now even in the national education policy also, lot of thrust it has been put on this particular area. Even the practicals, for the practicals, the distance education is making lots of researches, and those researches, they are talking that how to go for virtual practicals. Still, the UK Open University is also doing it. We have also experimented those things when the corona was there, and still we feel that the face-to-face interaction is very, very important. Therefore, we still organize face-to-face practicals, but we are also mentally preparing ourselves to see that how those virtual practicals, they can also be carried on. Today, I see that Professor Grover is with us, spared his valuable time. I know that for a professor of science and a distinguished professor, if he's sparing time and on that particular day, which is very, very important to every student, every teacher in the Faculty of Science, that is really a great thing for us. His support to us and his kindness to us. Because of that, we can receive those inputs, receive those valuable insights, and all those things, they may help us to see that how our teaching learning materials, how our teaching learning process, it can further be strengthened, and we can contribute significantly to our learners in the field of science. It is not restricted to the field of science, because science, it is everywhere. Even the social science is also a science. Computer science is also a science. So every discipline is having the elements of science, because they talk about the cause and effect relationship. So that is the crux for all of us. So whosoever are the teachers, whosoever are the learners, whosoever is the researchers, even the researchers also, social science researchers. And the research, it mainly talks about the cause and effect relationship. So everywhere the science is important. And therefore, anything which he says, we have to get those insights and try to see that how those insights we can transmit to our young learners who are spread all over the globe. My sincere best wishes on this great occasion, and my regards and respect to Professor Grover, who is with us on this great day, the Raman Effect Day. Thank you very much. Thank you.
Madam, your mic is muted.
Thank you so much, sir. Vice Chancellor, sir, for our encouragement, and we would keep on doing such activities beyond the course development, as you have said, to the expectations of the students and the university. Thank you so much, sir. Next, I would invite the speaker, Professor Arun Groverji, to.
Madam, I'll just make a formal introduction of 2 minutes.
Please. Before that, I was going to say, before he
yeah,
starts,
yeah.
Professor Bhaskar, please to introduce the speaker first to all of us.
Thank you, madam.
Thank you.
Thank you, Vice Chancellor, sir, for guiding us and gracing the occasion despite your busy schedule. I'm also equally grateful to Professor Arun Groverji, because he was in a convocation in Punjabi University, Patiala, and he has kindly accepted our request to have the lecture on this day. I made a small just 5 minutes PPT about sir, because I had the opportunity of working with sir in several capacities, and had the benefit of I'm not getting the screen. Why this is not coming? 1 minute. 1 second. There is an issue. Yeah, I got it. Yeah. Professor Arun Groverji is the Vice President of Society for Promotion of Science and Technology in India. As told by our Honorable Vice Chancellor, sir, he was former Vice Chancellor, Punjab University, Chandigarh. And at present, he is Honorary Professor, Department of Physics, and in Punjab Engineering College, deemed to be University, Chandigarh. He is a condensed matter physicist from TIFR and is the 12th Vice Chancellor of Punjab University, Chandigarh. He received the prestigious Homi Bhabha Science and Technology Award of BARC in 95 for his contribution to magnetism and superconductivity. He is a fellow of National Academy of Sciences, India, and of Indian Academy of Sciences, Bangalore. And he was the Vice President of Indian Academy of Sciences, Bangalore from 2016 to 18. And one of the important initiatives, which our Vice Chancellor also mentioned, that he was appreciated because of his new idea in which nucleation of Chandigarh Regional Innovation and Knowledge Cluster, which brought all institutions in the same platform, common platform to share the facilities and knowledge. In addition to all this, there is a very big CV. I am not going to read all those things, but briefly, he is a Senate member at PU Chandigarh, Punjab University, Patiala, IIT Ropar, and he is member of Board of Governors, Punjab Engineering College. He is chair of the Research Advisory Committee in IISER Mohali, and he was also a postdoc in London Imperial College, which is very prestigious. He is chairperson and member of various national committees. He has several talks, convocation address of academic institutions, and TV and radio talks. He has over 200 research publications. He has edited book, and as our Vice Chancellor rightly mentioned, today he has spared time for us, which is a great thing. And sir, we are grateful that you joined. May we kindly request you, with the permission of Honorable Vice Chancellor, to start the lecture.
May I start?
Yes, sir.
Okay. Good afternoon, all. So to start with, I would like to thank Professor Bhaskar, Professor Meenal Mishra, Punita Malhotra ji, and the Vice Chancellor, Professor Nageshwar Rao, for an opportunity to deliver a National Science Day lecture at the Forum of School of Sciences of IGNOU. We are all familiar that Raman has been the only Indian to receive the Nobel Prize in Science for the work done in India since the institution of Nobel Prizes in the year 1901. We just heard that he received the Nobel Prize for initiating the understanding of their own discovery on February 28, 1928. And the Nobel Prize got awarded to him within 2 years in the year 1930. So I personally became interested in the sociology of Nobel Prizes very recently, few years ago, via the publication of a book on Indian woman physicist Bibha Chaudhary. This book was written by Professor Sukumar Roy and the science historian Dr. Rajendra Singh from Germany. And the book was published in the year 2018, and the book is titled Bibha Chaudhary, Jewel Unearthed. Why Jewel Unearthed? Because this book narrates a story how Bibha Chaudhary and her supervisor, Professor D.M. Bose, were the first to identify heavy electrons, that is, electron-like particle having mass 200 times that of the electron, in the photographic emulsion plates which were exposed to cosmic rays in Darjeeling in the early 1940s. For a work which is a follow-up of Bibha Chaudhary's work, a Nobel Prize got awarded to C.F. Powell in the year 1950. Of course, he had to do many technical improvements and also provide some additional understanding. All the same, the Nobel Prize went to C.F. Powell, and C.F. Powell acknowledged 10 years later that he got the lead from Bibha Chaudhary. He also got lead from few other persons. So, but all the same, Bibha Chaudhary got denied credit when it was when it ought to have been due to.
Sir, if your PPT you're presenting, it is not moving.
No, I have not yet
Next slide,
started.
if you're giving.
No, I have not yet started moving the slide. Not yet. I am just in the introductory remarks. So, publication of this book on Vibha Chaudhary had stirred the Indian community, particularly scientists in Calcutta, because people in Calcutta felt that it is the third time that the Calcutta scientists had missed the Nobel Prize in Physics. The earlier two misses has been Sir Jagdish Chandra Bose and Meghnad Saha. So today's talk before you is, as I have written, is my comprehension of how C.V. Raman managed to safeguard his discovery and managed to get the credit for which was rightly due to him. So with these introductory remarks, let me just move on. Okay. So Indian Academy of Sciences published two books. Not published, they reprinted two books in the year 2017 and 2019. So just about 5 years ago. So the talk I am giving today, I couldn't have given it 10 years ago because I relied heavily on rereading of these two books. Okay. Is the slide moving now?
Sir, we are in the first slide. Yeah, ho gaya? Okay, sir.
Are you able to see the second slide?
Yes, sir.
Okay. So I said I couldn't have given this talk 10 years ago because I am relying on rereading of two books which were reprinted in the year 2017 and 2019 by Indian Academy of Sciences, and they were distributed to all the fellows of the Academy. So one of these books is titled C.V. Raman, a Memoir by A. Jayaraman, who was a student of C.V. Raman at Raman Research Institute. That is, after C.V. Raman had finished his innings at Calcutta and also completed his tenure as a director of Indian Institute of Science, Bangalore, and he founded a new institute where Jayaraman was his first student. And there is another book which was reprinted, that is Raman, a Pictorial Biography, and that was compiled by Ramasheshan and Ramachandra Rao, and I took lots of pictures on this as the time went by. So while serving as on the Research Council of NPL, I also became aware of the biography of Raman's student, namely K.S. Krishnan, who was the first director of National Physical Laboratory. So this biography is by D.V. Malik and Sabyasachi Chatterjee, and it was published by the University's Press. In addition to that, the Nobel Prize Foundation, they made available material which is more than 50 years old in the form of an access to their archives. So the science historians started to browse through that. So Rajinder Singh also browsed through that archives on Nobel Prizes. And he had, before that, he had written a PhD thesis on Raman, and for that he had got a DSc awarded by the University of Hamburg. In particular, Rajinder Singh wrote an article, which was celebrating 90th anniversary of Raman effect in the Indian Journal of History of Science. And this was, before that he had written a book which is called India's Nobel Prize Nominators and Nominees. So 1, 2. Then he wrote another book which is C.V. Raman's Laboratory and Discovery of Raman Effect and C.V. Raman and the Press. So I read through all these books, and on the basis of all my readings, I reckon today that Raman managed to get the Nobel Prize by virtue of his tactful perseverance. He was well aware how Jagdish Bose had not been even considered for the Nobel Prize 2 decades earlier. So, bit about Raman. So I am going to present you a few slides which tells you Raman's stay in Calcutta from 1907 to 1932. So Raman wanted to be a scientist or a civil servant, but he couldn't go to England. He finally wrote the Revenue Service examination and he arrived in Calcutta as a civil servant in the year 1907. And then he started to carry out research at Indian Association of Cultivation of Science. And that research got noticed by the legendary Vice Chancellor of Calcutta University, Justice Ashutosh Mukherjee. And on the basis of this passion that Raman had for science research, and which he was doing besides his job as a civil servant, okay, the Ashutosh Mukherjee managed to entice Raman to resign from the government service and accept the Palit Professorship of Physics. So Raman had raised an endowment from a rich lawyer of Calcutta, and from that he generated lots of things. One of them was the Palit Professorship for Physics, a Palit Professorship for Chemistry, and lots of research associates which were attached to this foundation. So Raman initially was interested only in acoustics of musical instruments, and on the basis of formidable work that he did in the field of acoustics, the Calcutta University gave him an DSc honoris causa in the year 1921. And after 1921, he went abroad for the first time. Okay, he was in England and in Canada, then in America. And on coming back from his trip from abroad, he intensified the research now on the scattering of electromagnetic waves in the form of visible light and the X-rays. So he was started to explore, okay, what happens when you scatter the visible light or the X-rays by transparent liquids. So he also wrote a monograph, The Molecular Diffraction of Light, on returning from his trip abroad. In 1923, his student K.R. Ramanathan observed a feeble fluorescence, okay, on scattering of light by pure water. So Raman put him on to studying this scattering of light by transparent liquid. So first liquid studied was water, and while exploring that, he found a feeble fluorescence in it. So after 23, Raman had another student who had worked with him, B.B. Ray, and after B.B. Ray finished his PhD, Raman sent him to work as a postdoc with Sigbaum in Sweden and with Niels Bohr in Holland. So both Sigbaum and Niels Bohr won a Nobel Prize. Bohr had got Nobel Prize in 22, and this Sigbaum got the Nobel Prize in the year 1924. So Ray came back to Calcutta, but he kept contact with both the Nobel laureates. So after the discovery of Raman effect, when Raman's name was being considered for the Nobel Prize, in the summer of 1990, Sigbaum tipped B.B. Roy obliquely for the award of Nobel Prize to Raman, and that is how Raman had this prior information that he is going to get the Nobel Prize that year. So several months before the prize was announced, Raman had already bought tickets via steamship to go to Sweden, and he was there to receive the prize in December of 1930. If he had not bought the tickets in advance, he wouldn't have been able to do this. So, okay. So, in the birth centenary year of Raman, the Indian Academy of Science commissioned a biography of Raman by Professor G. Venkatraman. Raman was born in the year 1888. So, in 1988, this book came up, which is titled Journey into the Light. So, in that book, G. Venkatraman beautifully acknowledges Professor Justice Ashutosh Mukherjee for identifying the scientist in Raman and supporting Raman for all the work that he was doing. So in the Senate meeting of 1920, December of 21, Ashutosh Mukherjee had remarked that his striking investigations in various departments of physics, particularly in the ever-widening field of theory of vibrations being both light and sound, have attracted respectful attention at the highest scientific circles in Europe and America. Ashutosh Mukherjee had also recognized Raman's talent as a teacher and as a science leader, and Raman had indeed set up a vigorous school of physics that had sprung up for the first time in Calcutta. And he, marked that he says for the first time in Calcutta. Prior to Raman, Jagdish Bose also had been there at Calcutta. So has been Acharya Praful Chandra Ray. So there was a eminent physicist, chemist, and mathematician, but they couldn't stir the young people in large number in a manner that Raman started to do after leaving the civil service and serving as a Palit Professor of Physics from 1917 onwards. In the meanwhile, Ashutosh Mukherjee had also started this new College of Science in the year 1916, and where he employed all the fresh toppers of MSc. So Satyan Bose, Meghnad Saha, J.C. Ghosh, S.K. Banerjee, all the toppers in physics, mathematics, and chemistry, they were employed in College of Science as kind of research associates come teachers. So they were not only teaching the further batches of MSc students, but they were also engaged in research and looking at Raman as an example to do research at the highest level in science. So Venkatraman further goes on to say that Raman described his Calcutta days as a golden era. And Venkatraman even says that even if Raman had not discovered the effect named after him, still he did voluminous work, very important work, that he would have still been recognized as a great scientist for the 20th century. And Venkatraman says that starting as a soloist, he quickly became a superb conductor of good orchestra without at the same time losing any of individual virtuosity. So, I mean, he sort of motivated everyone, but it was not that he allowed and everyone to grow individually and become leaders, science leaders in their own way. So Venkatraman also writes that on the average, for these 25 years that Raman was in Calcutta, he had nearly 20 researchers collaborated with him at any time. So now you can imagine the number of years that he spent in Calcutta and the number of people that he inspired. So that is why the science in Calcutta became so vigorous so long as Raman was there in the first half of 20th century. So let's move on to Raman effect. So yeah, there's one slide has got missing. I don't know what happened to it. Oh, has that happened? Why is it not moving to slide 8? It's moving to slide 11. Let's just me check. There is some problem in projection.
Here it is okay, sir. Here it is okay.
On my screen it is coming 11.
Okay.
Can you see slide number 8?
That is Raman, its true identification. G. Venkatramanan further states, C.V. Ramanan summary 3.
7. No, the slide number 8 has to be.
It is moving.
No, it is moving, but this is not the correct slide.
Network issue ho gaya hoga.
There's a slide which says. Let me just load this PPT again because of several slides are missing.
But we are able to see, sir. There is no issue.
No, because you are able to see because you don't know what was number 8.
Okay.
So this was sixth number slide.
7, 8, Yeah.
यहाँ पे वहाँ पे slide. अब उनको
Can you see now? Hello?
Yes, sir.
Can you see slide? C.V.
Yes,
Raman
sir.
International Science Day.
G. Venkatraman further states,
Slide 8. No.
I don't know the number. It says Raman often described his Calcutta days as golden era, with good reason.
No, it's still not coming. 8 is not coming. Wait.
sharing stop.
Namaskar, sir. I think 8 number is a background.
Wait. Background, yes.
Yes,
Are
sir.
you able to see it now?
No, sir. Please share again.
You close this and we reload the talk.
Yeah, yes, sir. Yes, please reload the data.
Please reload the talk. Why did it do this? Reload it on the next one here.
He's asking if they can see now.
Can you see it now?
Yes, sir.
Yes, sir. It's visible. Yes, sir.
C.V. Raman and National Science Day.
Yeah. Okay. Fine. I'm sorry for this, Mac.
No, sir. Sometimes we also experience very bad situation in the internet.
Okay.
Okay, sir.
So, National Science Day. So, as I said, on the National Science Day, National Council of Science Museum said the National Science Day should be celebrated on February 8 in the year 1987. So, it's from 1930 to 1987, we didn't think of commemorating this day, and it was done only in 87. And on that particular day is not the day that the Raman effect was discovered. It is on that day Raman understood what the Raman effect is, and he disseminated that understanding via press release. Okay, and that is why this Science Day is on February 28 and not on the day the Raman effect was discovered. So, and this news, it was a leap year, so the news appeared in the newspapers on February 29, 1928. So that is why sometimes this Science Day is celebrated on 28 or 29. Okay. So on February 26, this is the day prima facie the Raman effect should be considered as having been discovered. The effect, because on February 16, 1928 is wrong, it is not 2028. Raman and Krishnan had telegraphically submitted a 3-paragraph research note. On February 16, 1928, Raman and Krishnan submitted just 3 paragraphs. It was just a research note. It was titled A New Type of Secondary Radiation. So February 16, the note is submitted and it appears in the Nature on March 31, 1928. Okay. So, and what this research note claimed that if newer feeble radiation has been identified after scattering of sunlight through a liquid. So Raman's student K.R. Ramanathan had found a feeble fluorescence in 1923. Okay. So observation is the same, but it is not fluorescence anymore. Okay, it ought not to be considered as a fluorescence phenomena. Same phenomena, they think it is not a fluorescence phenomena, but it is a new feeble radiation, which has a frequency lower than the frequency of the incident light. And this newer radiation was also partially polarized. So it is, so 5 years down the line, same observation is being marketed differently. Okay, so all this, now you can understand the difficulties in the claim for a Nobel Prize. There is an observation not understood properly. 5 years down the line, there is an observation which is being projected differently, but still not being fully understood scientifically. Okay, so after February 16, between February 17 and February 28, next 11 days, Raman had figured it out, okay, that the new radiation that they are projecting, okay, that has a different frequency than that of the incident light. Initially, it was qualitatively, new radiation has degraded frequency. But degraded means what? So Raman figured out on February 28 that it had a different frequency and of course also different wavelength than that of the incident light. So this he felt was a new phenomena. So he called the press and shared his understanding on February of 1928. So on the very next day, all the newspapers in Calcutta as well as elsewhere in the world, they carried this headline, "Scattering of Light by Atoms, New Phenomena, Calcutta Professor's Discovery." Okay, and it also said, Raman had said that he will present the new results in a seminar in Central College, Bangalore on March 16, 1928. So this paper, this work, okay, Raman projects it as his own discovery. Okay, of course, lots of people are working with him, but this understanding, he has arrived on his own. None of his students had a role in arriving at this understanding, because the result had been there with them for 5 years. So before going to Bangalore, on March 8, 1928, Raman sent another research note to Nature, which was titled "A Change in Wavelength in Light Scattering." Now this note, okay, did not carry the name of Krishnan. This was a note only in the name of Raman. Okay, and how did Raman arrive at this conclusion? In addition to the sunlight, he repeated these Krishnan Raman experiments using a mercury lamp as a source of light. Okay, so Raman added this mercury lamp as a source of light to really understand what was happening there. Okay, and so this was carried in this March 8 paper. When he gives a seminar on March 16, 1928, Raman showed a spectrum which was photographed by Krishnan using the mercury lamp and a Hilger and a quartz spectrograph. Spectrograph can sort of distinguish between various colors of light. So Raman had they had all these instruments in that lab for last 5 years, but they had not employed it to see something which had been bugging Raman for 5 years, ever since the first observation. So Raman went and gave this talk in Bangalore. Coming back from Bangalore, he used the Calcutta University Press to bring out 1,000 copies of a new paper that he wrote, namely whatever he presented in the lecture. He sent another paper for publication in the Indian Journal of Physics, and 1,000 copies of this paper he sent it all across the world. We talk of preprint era now, but Raman knew what he had discovered and he didn't want to lose any credit, and he wanted the whole world to know what new he has found. So he used his great stature that he had in Calcutta by virtue of what Ashutosh Mukherjee had blessed him. Ashutosh Mukherjee, of course, had passed away in 1924. Now Raman was on his own. He was the secretary of Indian Association of Cultivation of Science, blah, blah, blah. So he used all his clout and made sure that this new result made known to rest of the world. So another few days later, on March 22, 1928, Raman and Krishnan submitted a third manuscript to Nature. And this manuscript was titled The Optical Analog of Compton Effect. Now, this optical analog of Compton effect was inspired by the fact that Compton had visited India in 1926 at the invitation of University of Punjab at Lahore. So Compton had arrived in India at Calcutta, and when he arrived in Calcutta, he had met Raman. Why he met Raman? Because Raman had visited Compton. Raman had met Compton first in Canada, and thereafter Raman had met Compton also in his lab in America. So Compton had, whatever Compton had discovered, that received the Nobel Prize in the year 1927. And Compton's work was also related to X-rays being scattered by outer electrons of any atom. So in Compton effect also there is an incident radiation and there is a scattered radiation, and both of them have a different frequency. So Raman felt it's a similar, there is an observation analogous to Compton that incident radiation has one frequency, and after scattering through the material, what you are observing are two different frequencies. So he felt as if he had discovered the optical analog of the quantum effect. Okay, so this is Rajinder Singh's book, Raman and the Press. So it shows this Raman, who had drawn this, schematically drawn, okay, what he felt would happen when the spectrum is photographed properly. So Raman put the date of his discovery as February 28, 1928 in this sketch, which he shared with the correspondents on February 28, 1928. So this sketch was finally confirmed by recording a spectrum, and the spectrum was recorded by K.S. Krishnan. And once they had the real spectrum on the lines of what Raman had guessed, okay, another paper was written, okay, and but paper was right. There it had detailed results, but the analogy with quantum effect actually was erroneous. And later, Raman never pushed this analogy with quantum effect later. So this is just the 1,000 reprints that Raman had brought out, and this is a copy that he had sent to Niels Bohr in Holland. And it has, things may not be visible, but it has Bohr's name in it. So this is what Raman had sent to claim that he was the first to discover a new observation. Okay, so now some extracts from the paper that Raman had submitted in his own name. Okay, so in the paper carries the name of Raman, but in that paper, Raman says, further observations by Krishnan and myself, okay, have been made and have led to some very surprising and interesting results. So experimental work, Krishnan is involved, but in enunciating the understanding, okay, Raman felt that he should get the precedence, so Krishnan's name is not carried. So he says, Raman says in that paper only, he says, modified scatterings appear as separate regions in the spectrum separated by a dark region. So this is the central observation which he had guessed, and he made a sketch of it, and which Krishnan verified by recording an actual spectrum. So this paper, the second paper that Raman had submitted, the Nature actually had sent it for referee, and one of the referees actually rejected the paper. So manuscripts ran rejected by one of the referees, but the second referee sent a telegram to the editor, okay, and that telegram became the basis for the editor to revise his judgment, and he let the paper be published in spite of the fact that one of the referees had rejected the paper, but the other referee took the proactive step of communicating with the editor that the result is essentially correct. So I don't want to go to the details of the Compton scattering, but in the Compton scattering, again, there is an X-rays which gets scattered from the outer electrons of any atom. So outer electrons of the atom have very low velocity, so as if the electron is at rest. So electrons are also there in the inner orbits, but in the inner orbits, the electrons have higher velocity and they are tightly bound to the nucleus. So, but the outer electrons are like free electrons, and there in the scattering, what is involved is only the mass of the electrons. But if you look at the inner electrons, then the inner electrons are tightly bound to the nucleus. So what is involved is the mass of the whole atom. So two things are scattering when you let an X-ray go through any material. So what comes out is a frequency which is almost like what the incident frequency is, and a scattered another line which is a scattered intensity. So the difference in energy of the incident light and the scattered light, okay, is a universal number. It doesn't depend on the characteristics of the material. Okay, and this was what the Compton effect was. So Raman had not identified this, but Raman identified something else. But he called it a Compton effect because initially they erroneously concluded that the separation between the incident light frequency and the scattered light frequency was material independent, but actually it was material dependent. So anyway, we'll come to that later, but the referee who sent a telegram to the editor, he wrote, okay, what he wrote was that he had verified Raman's discovery in every way. And he says, it appears to me that this very beautiful discovery, which resulted from Raman's long and patient study of the phenomena of light scattering, is one of the most convincing proofs of quantum theory. So it is 1928. Okay. No Nobel Prize has yet been awarded for the quantum theory. Schrödinger hasn't got the Nobel Prize. Heisenberg hasn't got the Nobel Prize. Of course, Planck got the Nobel Prize after 20 years of wait for the quantum hypothesis. Einstein also got the Nobel Prize for photoelectric effect, which again is a quantum phenomena, okay, after 15 years of wait. But here is this convincing proof of quantum theory coming from the Raman's work. And who is saying this? It is being said by R.W. Wood. And R.W. Wood was considered one of the most distinguished optical physicists of his times. And Niels Bohr had actually nominated R.W. Wood to get the 1929 Nobel Prize in Physics. Bohr had said 1929 Nobel Prize should either go to Wood or it should be shared with Raman. Raman doesn't know that Niels Bohr had already nominated him for the Nobel Prize in the year 1929. So, and Raman has been sort of, campaigning that people should nominate him. He had Summerfield had visited India in the year 1928. He went to Calcutta to see what Raman had discovered. Raman had lobbied with Summerfield to nominate him, but Summerfield did not nominate him. But Bohr on his own had nominated him in the year 1929, but Raman did not get the prize and did not get considered in 1929 because the 1929 went to de Broglie for for enunciating the concept of matter wave. So by 1928, when Raman discovers his effect, Okay, even de Broglie has not got the Nobel Prize for enunciating one of the fundamental postulates of quantum physics. So fine. So how difficult or easy is to observe the Raman effect? Anyone may ask. So this is an extract from a foreword of a book by on Raman by his student who joined him in 1948 or 1949. He says, during early years of Raman Research Institute, we did not have electricity for a long time. It took 18 months to complete electrification after my joining. So he joined in 1949. So there was no electricity in Raman Research Institute in 1951. So, but it's not that he wasn't doing anything. The experiments of light scattering can be done with the sunlight. So one day when he was working, okay, Raman asked him to direct a beam of sunlight reflected by a mirror from outside to do some beautiful work on optical phenomena exhibited by a class of minerals. So this is what he was studying, scattering of light by the lots of crystals which Raman had collected all his life. And Raman visits him in the lab, and then he shows him the Raman effect by letting the sunlight scatter through those crystals. You can scatter the light also through the liquids to observe the Raman effect. So Jayaraman says, I did not realize at that time that the Raman effect was discovered using sunlight, and the Raman effect could be seen as easily as Raman was himself demonstrating to him. So this is a schematic diagram which is from the biography of Raman, written on the centenary of Raman. So what is the Raman effect? You take sunlight, you put a violet filter. So what comes out of the violet filter is a violet light. So here is a transparent liquid, and you scatter the liquid, this light through this thing, and observe at right angles. When you observe at right angles, you have something which is an equivalent of incident radiation, and then there is a scattered light. Now, both these have different colors or different frequencies. So you put a filter and block the incident light. What comes out is only the scattered light. So, okay, so you start with a violet light, and what you see here is a green light. So this is all that is Raman effect. So this is how it is so easy to observe Raman effect prima facie, and you don't need electricity to observe the Raman effect. So a group of school students has visited Raman much later. They were all school students, Tamil medium, and they asked Raman to explain what the Raman effect is. So this is Raman's explanation to those school students. He says, Raman says in Tamil to the school students, think of a person throwing a tennis ball, okay, at a certain speed to a tennis player who is waving his bat back and forth. So there is, you throw a ball, and there is a tennis player who is waving his bat back and forth. Now, some balls will hit the bat when the bat is going forward, and some will hit when the bat is coming backward. So sometimes the ball that is thrown, it will lose energy, and sometimes it could gain energy. So this was Raman's simple explanation to the Tamil school students. And Jayaraman writes, I don't know whether the kids understood what Raman was telling them in Tamil, but this was Raman's easy way of explaining whatever he had observed to the young school students. So now Raman effect had caught the imagination of one and all. So this is a slide which just tells you how the would-be Nobel laureate Davison, who was in Bell Labs, how he explained the Raman effect to all his colleagues. You can read about it later, so you will have that transparency with you. So Davison said Raman effect is universal. Raman effect reveals previously unknown process, and it is a new and convenient method of investigating energy levels of molecules. So the difference between the incident and the Raman line depends on the scatterer. And it not only depends on the scatterer, but it also depends on the chemical nature of the scatterers. And that is why the Raman effect became a powerful tool, and that is how Raman could manage a Nobel Prize so soon after the discovery of the Raman effect. See, Raman was nominated for Nobel Prize, as told you, by Niels Bohr in 1920. Niels Bohr and C. Fabry in 1929. In 1939, Raman was nominated again by 8 or 9 people, and these included E. Bloch, Niels Bohr, both the de Broglie brothers, Olson, Perrin, Pfeiffer, Rutherford, Stark, C.T.R. Wilson. 6 of them had received Nobel Prize prior to Raman. So many Nobel laureates got together to push Raman as a candidate for the Nobel Prize. And Raman, of course, knew that whatever he has discovered would get a Nobel Prize. I mean, the understanding that he was seeking of the 1923 observation that was made by one of his students, he knew that if he understood it, he will get the Nobel Prize. This is taken from a publication which was there in a newspaper in Caltech in November 18, 1924. And what does it say? He says, a European scientist visiting the Caltech recalled that he met a scientist from India who imagined that he was going to discover a quantum effect in light scattering, which would win for India the Nobel Prize. So this is 1924. So Raman knew all the time that there is a Nobel Prize hidden in this observation. I thought that the scientist who is recalling, he says, I thought that he was crazy. The incredible thing is that this man does make the discovery and does get the Nobel Prize 6 years later. So this is Raman with Niels Bohr, and this is Raman with Millikan, Robert Millikan, who had invited Raman to visit California in 1924, and this is Millikan visiting Raman's Indian Institute of Physics Laboratory in the year 1940. So, all right. So, again, this is a headline in California Star News, Pasadena Star News. This is where the Caltech is located. It says, scattering of light and its relation to atomic and molecular structure. This, Raman had guessed that if he understands it, it will reveal something about atomic and molecular structure. And Raman had stated both the physicists and chemists, Raman believes, have left a neutral place between their theories so as to the construction of atom, especially as those theories applied to light. And his mission was to give each food for thought so that the two great sciences might be brought together. So Raman knew that there is an observation in which is hidden physics and chemistry both, which is at the border of physics and chemistry, a physics observation which will reveal the chemistry. So this is what eventually happened, and this Raman's talk was listened to by 300 students, teachers, graduates, etc., etc. So, was Raman alone in exploring whatever he was doing? No. Many people were exploring the scattering of light through matter, whether it is liquid, gases, solids, and so on. And there are many theorists who are also working on it. What happens when the electromagnetic waves travel through matter? So there are one such person was a theoretical physicist, Smeckel, who had showed that due to quantum nature of light, monochromatic beam of light after scattering would not only have original frequency, but also frequencies of higher and lower wavelengths. So this theoretical physicist had guessed. And this is 1923 and 1925 published in Germany. So he is theorist. So he is treating the incident light as a monochromatic beam of light. But the experimentalists are all doing experiments with visible light, which is made up of all frequencies, the entire spectrum of the visible spectrum. So they are not carrying experiments with a monochromatic light. I mean, there were no lasers there. So they are not doing the experiment with a monochromatic light. They are doing with a whole spectrum, visible spectrum. So they are finding it difficult to verify what this guy has predicted it as early as 1923 and 1925. So this was a phenomenological way of doing it. But Heisenberg, in partnership with Kramers, okay, treated the Smeckel's problem quantum mechanically, and he came at the same result. And Heisenberg's results were also published in the same German journal, Zeitschrift for Physics, in 1925. So there is a lot of this theoretical work which is predicting, okay, what should be observed and what Raman had observed. But Raman had not referred to Smeckel's work at all. Raman had, of course, tried to identify what he was doing with the Heisenberg's work, but not with the Smeckel's work. So as you will see that all these are competitors with Raman when the Nobel Prize considers the discovery by Raman's group. So of course there are people also in Russia. Okay, right. So Russia had two competitors, Landsberg and Mandelstam. So they had also seen this phenomena in the year 1928, and they had seen the phenomenon February 21. That is 5 days after Krishnan and Raman had sent their paper. So paper had not yet been published. So these people had also discovered this same result via scattering of light from the quartz crystals. And they were also nominated for Nobel Prize, and the Russians still call it as a Raman, Landsberg, Mandelstam effect. So Russians sent their results on February 23, and their paper got published only on May 6. And Russian by that time had come to know what Raman had done, so they actually quoted Raman's February 16 paper. So that is how somehow they did not get considered. So Raman had many competitors. Landsberg and Mandelstam were there, and someone who nominated them, he argued that Russian had written their communication on February 21, 28. Their publications would have been earlier than Raman's account of February 28. So they have done it independently, so they should not be discounted. So problems for Raman. Raman, of course, had compared his work with Kramers and Heisenberg. So if you are comparing your work with some theoretical result, that theoretical work has come out independently. So Heisenberg also is a competitor to Raman. So there is an extract from K.S. Krishnan's diary, which is dated February 7. So this is 9 days before the first publication is set. He says Raman had asked Krishnan to look at this effect. Krishnan had worked on it for a few years, then he left it. Then long story short, Raman had asked Krishnan to look at these things again. So Krishnan starts to look at it, and on February 7, he says some results he had recorded in aromatic liquids, and he says, when I told about the results, I mean when Krishnan told about the results to Raman, Raman would not believe that all liquids can show polarized fluorescence. And ultimately it is not fluorescence, can show polarized light as a secondary emission from the liquid. So Raman says, you mean all this is fluorescence? He wondered how we missed all this 5 years ago. So it's clear that K.R. Ramanathan had made this observation, did not understand it, did not pursue it. Raman also did not pursue it or pursued it, but did not think that fluorescence was a new radiation. I thought of this new radiation having frequency different from the incident frequency. That comes on February 28, but the discovery is announced to the world via Raman Krishnan paper on February 16. Okay. So there are many competitors. From within India, there is Krishnan, there is K.R. Ramanathan, then there is also Venkateswaran, who gave a clue to Krishnan to do things in a certain way. So there are Russians who are competitors, there are French also who are competitors. So Raman is now trying to argue why he has precedence over everyone. So this is what Raman told to a journalist in Calcutta on May 31, 1928. So he says, French School of Physicists under Professor Fabry and Brouillon are very excited about the discovery. And within a week of the news of reaching Europe, 2 papers have been published by the Paris Academy of Sciences, okay, commenting on it as an extremely remarkable discovery. But they were already working on it. So whatever they have done, they also quickly sent it for the publication. And Raman, of course, protested to Russians, okay, and he even wrote a very nasty letter to them. And he says, I trust this omission will be corrected in your future publications on the subject. So Raman was very not happy with what Russians were doing. And this is what Einstein wrote in 1953 on the 25th anniversary of Raman effect. Raman was the first to recognize and demonstrate that the energy of a photon can undergo a partial transformation within the matter. So Einstein, of course, is able to see this because Raman had a colloquium given on it in Berlin. He says, I still recall vividly the deep impression that this discovery made on all of us who at the time attended the physics colloquium in Berlin. So Raman's work had been talked at a colloquium in Berlin, and Einstein remembered that the new discovery is due to Raman. So all this is published in the PhD thesis of Rajendra Singh, for which University of Hamburg awarded him a DSc degree. So Raman, again, writing to Nature, Raman had a showdown also with English physicists, namely the grandson of Charles Darwin. His grandson had gone to Russia, seen the Russian work, and he was sort of praising the Russian work and trying to give them the credit, and Raman was very angry. So Raman wrote to Nature, he says, investigations at Calcutta had established the modified wavelength in the light scattered by liquids and solids as early as 1923 by K.R. Ramanathan. And he says, further studies in the numerous substances were described by Krishnan in 1925 and again by Raman himself in October of 1927. Then Raman says that he showed all these things in the talk in Bangalore, and he sort of says that the world was being unfair to him and the credit belongs to him. So Raman had sought nomination from Niels Bohr in 1929, and he didn't know at that time that Niels Bohr had already nominated him for the Nobel Prize independent of Raman lobbying with him. So this is Niels Bohr, who had got the Nobel Prize in 1922. So this is De Broglie, who got the Nobel Prize in the year 1929. So in 1929, there were 48 nominators had sent 97 proposals. So Raman's nomination in 1929 was one amongst the 97 proposals. Of the 97 proposals, he got the Nobel Prize in the year 1929, De Broglie. Okay, and next year it's the turn of Raman. Next year also there are many nominations. Okay, both in the terms, Mandelstam has a nomination. One of the nomination is give half the prize to Raman, rest to the Russians. One prize is give it to Wood and Raman, give it to only Wood, give it to Raman and Wood, give it to Raman and Heisenberg, or give it to only Raman. So there are all these plethora of nominations are there for the Nobel Prize in the year 1930. Nobel Committee, of course, gets everything evaluated. So Rutherford and Wilson had also written a note to the Nobel Prize Committee. It says, we are of the opinion that Raman's work is of outstanding quality required for this. Experts and the committee says no shared prize. So Raman doesn't have to share prize with the Russian. Raman doesn't have to share prize with the French. And the committee's expert says Raman method has been applied with great success in different fields of molecular physics. And Raman effect has effectively helped to check the actual problem of the atomic physics. And this is why first the Nobel Committee sends everything for experts' opinion. After the experts' opinion, okay, then the Nobel Committee meets, and Nobel Committee then says that Raman has shown the universal nature of the phenomena, and they discount everyone else And lo and behold, the Nobel Committee has decided to ask the Academy to award the Nobel Prize Physics for the year 1930 to Chandrasekhar Venkatraman Calcutta for his work on the diffusion of light and for the effect named after him. So this is Ramanathan for you, this is Krishnan, and this is Venkateswaran. So he observes it first. He provides the lead for Krishnan to do repeat experiments, what he had done for 3 years after K.R. Ramanathan had got his PhD and taken up a job in the meteorological lab and so on. So, but these three people have a significant contribution in pushing to the final stage. So they, in some sense, they would be competitors. So February 9, 1928, Diary of Krishnan. Okay. So what does Krishnan says? He says, so Krishnan had shared used to share everything that he was doing daily. And professor comes to meet him. He says, when professor came from the college at about 3 in the afternoon, I announced to him the result, and there was still enough sunlight for him to see for himself. He ran about the place shouting all the time that it was first-rate discovery, and he was feeling miserable during the lecture because he had to leave for the experiment. And that, however, he was fully confident that I won't let the grass grow under my feet until I discover the phenomena and guesses. He asked me to call in everybody in the place to see the effect and immediately arrange in a most dramatic manner with the mechanics to make arrangements for examining the vapors at high temperature. So Raman, they have seen it in liquids. Now Raman wants to see the same thing in vapors of those liquids. So for that new experiment has to be set in. So overnight the experiment is set up. So, okay, so now again the diary of February 9, Krishnan further writes. Okay, Krishnan further writes, Raman told Venkateswaran about the discovery and Raman was discussing the problem with us, and in the course of it, he said the phenomena should be called Raman-Krishnan effect. On February 9, Raman felt that the phenomena should be called Raman-Krishnan effect, and he told Venkateswaran would refer to this effect as a Raman-Krishnan effect. So Venkateswaran is out because he is asked to refer to as a Raman-Krishnan effect. And eventually, Venkateswaran refers to it as only Raman effect, so Krishnan also gets out. And Raman actually told Krishnan that you may get fellowship of the Royal Society by virtue of this result before you can get your PhD. Krishnan had still not got his PhD when all this had happened. So, lo and behold, Raman got the prize. Krishnan grew up as a great scientist by his own virtue. Krishnan had great mathematical skills. He was at Dhaka for many years. He set up a group on magnetochemistry. Later on, became a Mahendralal Sarkar professor, and then came to Allahabad to occupy the chair which was vacated by Saha, etc., etc. Krishnan is chosen as the first director of the National Physical Laboratory, and then in 1953 was the 25 years of the discovery of the Raman effect. It is at that time K.R. Ramanathan, who had first observed this effect, he created a controversy by saying that it was not a great thought of Raman to use the Mercury lab to observe the same phenomenon on February 28, 1928. He said it was a cloudy day in Calcutta on that day, and that is why Raman used the Mercury lamp. It was not a great thought of Raman because use of Mercury lamp and monochromatic light was the key to eventual understanding of that effect, which had been haunting them for the last 5 years. So Rajinder Singh did his own homework, and it turned out he found out from the meteorological office that February 28, 1928 was a clear day. It was not a cloudy day. So actually Ramanathan had told a lie. Raman was very angry with Ramanathan. He made Ramanathan apologize for his misdemeanor because he was calling it a fluvial fluorescence. Whole lab was at his command. He never used the instruments at his command to do the right experiment after his first observation. So Raman was not happy that one of his well-known students, who was a great scientist in his own right and was also at one time the director of the meteorological lab in Pune, to have said this. Anyway, later on, K.R. Ramanathan was also the first director of Physical Research Laboratory, which Sarabhai had established. But, scientists are also human and sometimes mistakes happen. So, two scientists, S.K. Mitra, who had done his PhD with Raman, D.M. Bose, who was the nephew of J.C. Bose, okay, they had been invited by the Nobel Committee to make nominations. And Mitra, who was a student of Raman, never nominated Raman. D.M. Bose also did not nominate Raman. These two people went on to nominate, Meghnad Saha for his Saha ionization equation, and not Raman. And that is 1929. Saha, of course, never gets the Nobel Prize as the time goes by. This is Raman with Compton. Okay, and this is Krishnan, Sommerfeld, and Raman. So many students of Sommerfeld get the Nobel Prize. Many students of Sommerfeld got the Nobel Prize. Sommerfeld himself was nominated for the Nobel Prize more than 90 times, but Sommerfeld never got the Nobel Prize. This is Raman with Heisenberg. This is Raman with his nephew Chandrasekhar. Both of them received the Nobel Prize. He got Nobel Prize for Chandrasekhar limit, many decades later. So a result which he had figured it out in 1930s, he got the Nobel Prize almost 50 years later. This is a sketch of Raman drawn by Bhabha, and so Raman described Bhabha's portrait of him as a picture of one scientist by another. Bhabha said, no, it is a picture of one artist by another. Why? Because this is Raman as a scientist, as a teacher. And you can see Raman's art behind this blackboard. So thank you very much for your attention. I hope you enjoyed the talk. I took a little long.
Thank you, sir. You can.
So you are welcome to ask me question, clarification. I am prepared to answer everything. Hello.
Yeah, thank you, sir. It was indeed a very informative presentation. So if now the house is open for discussion, if there is any question, we can take the questions.
Any
Yes,
questions? please?
Yes, Pastor Grover.
Yes.
Yeah, I have learned a lot about Pastor C.V. Raman, but I didn't know the history behind all this thing. It is so thrilling, exciting to learn that how a Nobel Prize is in a position to get it. It is very difficult. I understand, and you have really explained in a very sophisticated and very nice manner. Thank you very much indeed for encouraging us all. Thank you very much.
Yes, Sunita ma'am, I think she want to ask. Yeah.
सर बहुत अच्छा इंटरेस्टिंग लेक्चर था. बधाई बहुत बहुत शेयर करने के लिए आइडियाज हम सब लोगों को. सर एक चीज बताइए, जैसे वो कहा था कि मतलब इट वाज एग्जांपल वाज जस्ट लाइक ए बैक एंड हिट बैट करता है फ्रीक्वेंसी. So was if the probability is taken equal or the frequencies are equal, तो बराबर का मैच था क्या?
No. Point is that anti-Stokes line, your gain in energy is there as well, but that happens in a fewer number of cases.
That's true, sir.
But
that's why only delta nu जो plus minus करते हैं, बराबर का वो रहता है.
But that's a simplistic way.
Simplest way. So वही कहने का मतलब था कि वो बराबर की frequency assume करके आगे चल सकते हैं.
But the shift is the same on the
Yeah.
both sides.
Yeah, shift is the same. Thank you, sir. Thank you once again.
Yeah, any more questions? Okay, if there is no questions, may I now request Dr. Venkataraman from Mathematics Discipline to propose a formal vote of thanks.
Very good afternoon to everyone who has joined this webinar on National Science Day to commemorate the discovery of Raman effect. On behalf of the Seminar Committee, Seminar and Cultural Committee, School of Sciences, it is my pleasant duty to deliver the vote of thanks on this August occasion. I thank Professor Arun Grover. Can you hear me?
Yes, sir.
I thank Professor Arun Grover, who has set aside time from his busy schedule to tell us about the discovery of Raman effect. I thank our Honorable Vice Chancellor for giving us the go-ahead and encouraging our effort to celebrate the National Science Day with his August presence. I also thank the Director, School of Sciences, for smoothing our path by putting a word where necessary and encouraging us. Thanks are also due to Professor Sachi Shah, Director of COE, for arranging live streaming of this function through YouTube. I thank Mr. Rajesh Sharma, CPRO IGNU, for arranging live streaming of this function on Facebook. I would also like to thank the fellow members of the Seminar and Cultural Committee for their enthusiasm in organizing this function. I thank Professor Bhaskar for proposing the speaker, Professor Arun Grover, and coordinating with the speaker and for introducing the speaker. I thank Dr. Kakoli Gogoi for creating the Google Meet link, sending out the invitation to directors of schools, the regional centers of IGNU, and to the speaker. I thank Dr. Manisha Pandey for coordinating with the COE and the CPRO for arranging the live streaming of the event. I thank Dr. Prabhat Singhal for arranging refreshments. Thanks are also due to Dr. Kakuli Gogoi for preparing the poster and the flyer. I also thank Dr. Neha Garg, Dr. Kakuli Gogoi, and Dr. Nimoy for taking up the responsibility of preparing a report of the event for dissemination of information about the event through DigiNews. Once again, I thank you all who have joined us through Google Meet, YouTube, Facebook. Have a nice day. Thank you.
Thank you.
Venkataramanji. Director Madam, if you permit, we can formally thank. Maybe you can thank, sir.
Yes, I would really like to thank Professor Grover and everyone present here, especially senior members like Kuldeep Basinji and others who joined, Suman Bari Madam and other gentlemen. I'm just forgetting the name. So
Okay,
thank you everyone for sparing the time and being with us. Really thankful. And more such occasions to meet you all, maybe offline or online, wherever possible. Sonuji, I can see you also. So my thanks to everyone, each one of you. Best wishes from my side and have good health and be with us always. Thank you.
Thank you for the invite.
Thank you very much.
And,
Thank you.
Arun
And
Grover,
freely
sir,
distribute this PPT.
grateful to you for sparing your time despite your busy schedule. Thank you, sir.
Thank you, sir.
Thank you so much.
Thank
So shall we close now?
you. Yes.
Thank you.
Thank you.